Hey everyone, and a huge welcome to all of you from the India AI Summit. So, you're a software engineer, you've built this amazing AI model, and you've shipped it. Job done, right? Well, not quite. We all know that's when the real fun begins. Today, we're going to build out the ultimate playbook for keeping that model healthy in production. Okay, so what's on the agenda? First, we're going to talk about this silent threat that can seriously mess with your AI once it's live. Then, I'll show you an awesome open source tool to have in your corner. And after that, we're rolling up our sleeves and getting practical. We'll cover everything from spotting data drift to building out that slick all-in-one dashboard. All right, let's kick things off with something that probably gives every developer nightmares. You've put in the hours, you've deployed your model, the metrics look fantastic, for now. But then comes that nagging feeling, right? You're just hoping it keeps working as the real world, which is always changing, starts throwing new stuff at it. And that leads to this huge question. Is your AI silently failing? Because here's the thing. It's not usually a big, loud explosion. It's not going to crash your server. It's more like a slow leak, a quiet decay in performance that you might not notice until it's too late. This right here, this is the villain of our story, data drift. It's a super simple concept, but incredibly powerful. The world your model was trained on is not the world it lives in today. User behavior changes, new slang pops up, trends come and go, and that gap between your training data and your live data, that's drift. And it's an invisible enemy that can completely tank your model's performance without a single warning light flashing. Let's make this real. Imagine you're running a fraud detection system for a big telecom company. Fraudsters are smart, they're always one step ahead. They might switch from using WhatsApp to Telegram for their scams. Or maybe Geo launches a massive marketing campaign and suddenly what normal user behavior looks like completely changes. These are perfect examples of data drift, and yeah, they can literally make your model useless overnight. So the big question is, how in the world do you fight an enemy you can't see? Just looking at your overall accuracy score? Nope, that's not going to cut it. You have to go deeper. So let's talk about the right tool for this job. And that tool is evidently AI. Think of it as your secret weapon. It's an open source framework designed from the ground up for AI observability. It gives you these incredible, deep insights into not just data drift, but also model performance and, super importantly, the quality of your LLMs. And if you look at how it stacks up against other tools, you'll see why it's such a game changer. It's got fantastic drift detection, great LLM support, but the key thing, it is completely open source. That makes it a no-brainer for really complex, high-stakes jobs, just like that fraud pipeline we've been talking about. Okay, theory is great, but let's get our hands dirty. It's time to look at some code and see how you can actually start catching these problems in your own systems. First up, let's tackle the most common kind of drift, the one you'll probably run into first, tabular data drift. You know, the classic stuff, data in columns and rows, like a spreadsheet. We're talking about your core features, things like call duration, risk scores, the numbers that are the bread and butter of your model. Now, check this out. This is the best part. Getting started is ridiculously easy. Seriously, look at this. With just 5 lines of Python, you can spin up this super comprehensive report. It compares your training data with your production data and checks for more than 20 drift metrics. That's a massive amount of value for like almost no effort. It's awesome. Okay, that's numbers, but what about text? You know, for all our fancy RAG systems, that's retrieval augmented generation, by the way. The meaning of words and phrases can shift over time. We call this embedding drift. And trust me, even a tiny change in the meaning of user queries can totally wreck your retrieval quality. And here's how you monitor for it. This little code snippet is absolutely critical for catching those semantic shifts. Let's go back to our fraud example. Maybe fraudsters stop talking about SIM swaps and start talking about WhatsApp OTP fraud. The goal is the same, but the language is different. This code catches that change. The cool thing is, you've got options here. This table kind of breaks down the different ways you can detect embedding drift. You've got to balance sensitivity versus speed, right? So if you want to catch totally new attack patterns, maybe a more complex model-based approach is the way to go. But if you just need a quick and dirty alert, a simple ratio check might be all you need. All right, so we've covered the input data, but we can't stop there. Especially when we're talking about LLMs and RAG systems, quality is a much bigger, much fuzzier concept than just checking if data distributions are stable. With any LLM pipeline, you have to constantly ask yourself these kinds of questions. Is the answer it's giving even relevant? Is it actually using the context you gave it? Or is it just making stuff up, hallucinating? Is it understanding what the user even wants? These are the things that really matter. So, how do you even get the data to answer those questions? Well, if you're using a framework like LangChain, it's actually pretty simple. You can use what's called a callback handler, just like this one on the screen. It basically hooks right into your agent and listens in on all the LLM calls, logging the whole conversation, the questions, the answers, so you can analyze it later. And why does this matter? The impact is absolutely massive. Think about it. A system with these kinds of quality checks can catch something like 85% of bad or hallucinated fraud recommendations before a human ever sees them. That is a huge, huge reduction in risk. Okay, final piece of the puzzle. We have all these amazing metrics, but you don't want them scattered all over the place. You're not going to dig through log files. What you need is a single dashboard, a single pane of glass where your whole team can see what's going on. This is basically your mission control center. One look, and you should know the health of your entire system. Everything from data drift percentages to LLM quality to latency, and even how much you're spending on tokens, all the way down to that final business metric, like your fraud detection F1 score. And a good dashboard isn't just for looking at pretty graphs. It has to be actionable. This table is a great example of how to do that. You set clear thresholds. If data drift on more than 30% of features is detected, boom, trigger a retrain. If relevance drops, page the on-call engineer. It connects the what to the so what. Whew, okay, we've covered a ton of ground here, right? From the high-level theory of why models fail, all the way down to the code and dashboards. Let's do a quick recap of the whole workflow, and then I'll give you the single most important first step you can take. So here it is, the whole shebang, the full production-grade pipeline. It starts with those evidently callbacks inside your agent, capturing data in real time. That data gets saved, and then you run daily jobs to evaluate it, which can fire off alerts to Slack and feed those beautiful trend charts in your Grafana dashboard. But look, the most important message I can leave you with is this. You do not have to build this entire thing tomorrow. Don't get overwhelmed. The biggest bang for your buck, the place to start, is with that callback handler. Seriously, it'll take you maybe 15 minutes to set up, and you will instantly start getting data on your LLM quality. It's a huge first step. So I'll leave you with this question. What's the first thing you're going to monitor?